Hello friends, welcome to Susan and John MathTube. Today we are back with another lesson, that is lesson number 8, and these videos are specially designed for the first year engineering students who are studying in TU affiliated colleges. So let's move ahead with lesson number 8. And before we start, as usual, how to use these video lessons effectively. So here we go. 1, 2, 3 and 4, and I hope you are following this. Okay, so let's start. So today it's one of the most repeated question, or let's put it like this: I have not seen a past paper question without this question. So you can understand the importance of this question. Anyway, it's about interval and radius of convergence. And before you start this video, make sure you're good with convergence and divergence. You can understand this only if you're very good with convergence and divergence test, including Leibniz test. And you can find the videos in my playlist. You can find the videos under the name convergence and divergence. Anyway, let's move ahead. So find the radius and interval of convergence of the power series sigma n x power n by 5 power n. Okay, look at this. This is not one particular series. This is a function of series because there's a variable here, and that means if you put x equal to 1, you'll get a series. If you put x equal to 0.3, you'll get another series. If you put x equal to minus 1, you'll get an alternating series. Like that, this is not one series, but it's many. Now the question is, what will be the interval of convergence? That means, what are the values of x which will give us series which converge? So actually it's not one value or two values, it will be an interval. So we want to find those values of x which will make the series converge. So let's start. So I have kept the question on the right side of the screen as always, and let's start. As always, let the given series be sigma un. Okay, so un is n x power n by 5 power n. Okay, now one important thing, we are actually going to use D'Alembert's ratio test, but when they ask radius and interval of convergence, it's slightly different. We go for modulus of un plus 1 by un. So anyway, we have our un and un plus 1, and okay, this is the limit, and I'm warning you, don't forget this modulus. I'll repeat, don't forget the modulus. So I'm going to plug in those values, the values of un plus 1 and un, and I'm sure you know 8 to the power m plus n is a power m into a power n. So 5 to the power n plus 1 will split and it becomes 5 power n into 5. Okay, and the same story goes for x power n plus 1. Okay, now let's cancel a few terms and you will end up with n plus 1 by n. This will get cancelled, so the remaining part. Okay, and I'm sure you're very good with limits which tends to infinity, and you take n outside, cancel. Okay, now when n tends to infinity, you're going to get 1 plus 0 into x by 5, so we get modulus of x by 5. I hope you're okay till here, and that will be mod x by mod 5. Okay, so I hope things are okay till now. Okay, this is the most important step. So I'm going to write like this. Therefore, sigma un is convergent if this limit is less than 1, divergent if the limit is greater than 1 and no conclusion. We don't know about it. In some books they will put test fails. So, okay, now look at this. We have to analyze this case. We are not interested in interval of divergence, so we will just ignore this. But we have to analyze this because we want a clear cut answer. Is it convergent or not convergent or divergent? So mod x by 5 equal to 1, and that means mod x is equal to 5. Now look at this. What is modulus of x is equal to 5? What does it mean? It means the values of x which will give an output 5. So what are the possible values of x? Okay, if I input 5, I'll get modulus of 5, that is 5. And if I input minus 5, I'll get modulus of minus 5, that is also 5. So there are two possibilities. So case number 1, x is equal to 5. Anyway, I have kept all the possibilities here. Now what we do is, take a look at the question. I will plug in this value, this x value over here. So I'll start. The given series becomes. So tell me what will happen if I plug in x is equal to 5. Of course, it will become 5 power n by 5 power n. And that will be sigma n. And sigma n means the counter starts from 1. So this actually means 1 plus 2 plus 3 plus dot 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 to infinity. And it is obvious the answer will be infinity. So we don't have to do any test. So obviously the answer is infinity. So the series is divergent. Now let's keep the fact here. That is, if x equal to 5, that was our case, then the given series, that is our sigma un, is divergent. Okay, let's keep it here. Now case number 2, when x is equal to minus 5. Now tell me what will happen if I plug in minus 5. Okay, before we start, tell me what is ab the whole power n? Isn't it a to the power n multiplied by b to the power n? Okay, so the given series becomes, I'll repeat, I'm plugging in x is equal to minus 5 over here, and minus 5 actually means minus 1 into 5. I'll repeat, I'm plugging in x is equal to minus 5, and that becomes minus 1 into 5. And I told you before, ab the whole power n is a power n into b power n. So I hope you are able to understand this. We plug in x is equal to minus 5, it becomes minus 5 the whole power n. And minus 5 is minus 1 into 5, and it becomes something like this. And that is an alternating series. I'll repeat, if you are not good with test of convergence, pause the video right now and take the playlist, and you can find convergence and divergence. And in that playlist, you'll find Leibniz test. First study that, and then you can continue with this. Okay, let's proceed. So this is an alternating series, and to test alternating series in your syllabus, you have only one test. That means you're going to apply Leibniz test. Okay, so let's write un and un plus 1. And I'm sure you know there are two conditions in Leibniz test. If one of them fails, then it is not convergent. If both of them are satisfied, then it is convergent. Okay, so number 1. Look at this. N and n plus 1. Is this big or smaller than this? Okay, that's it. Finished. Look at this. N is smaller than n plus 1 because we start counting n from 1. The first term, the second term, the third term. So you can plug in any of these numbers 1, 2. So 1 is smaller, 2, 3. So 2 is smaller. So the first condition is violated. That means the given series is not convergent when x is equal to minus 5. Okay, I'll keep that here. There it goes. Okay, now time to collect all these things together. So we know our series is convergent if mod x by 5 is less than 1 and divergent is mod x by 5 is greater than 1. Of course, I'm not interested in this. And we don't know anything about this. That means no conclusion or test fails when it is equal to 1. So we analyzed and we came up with not convergent when x equal to minus 5, divergent when x equal to 5. Now let's write everything together. So look at this. Now I'm cutting that no conclusion part and I'm copying these things. I hope you're able to understand this. Okay, now I will repeat. I am not interested in divergence. The question is find the radius of convergence, interval of convergence. So I'm not interested in divergence part. So I'll cut this, I will cut this, and I'll cut this. So I'm interested only in this part. So there it goes. I'll repeat. I'm not interested in any of these things because it tells me divergent, divergent, not convergent. But my question is find the radius and interval of convergence. Of convergence. Okay, so I'll focus on this. So this is exactly my interval. And that is okay. I hope in your younger classes you might have studied this. This implies x will be between minus k and plus k. And also this is called an open interval, so you can write minus k comma k. So there it goes, and that's it. Okay, now let's mark this in the real number system. Our minus 5 and plus 5, and the middle will be 0. So for your convenience, I will draw. I know it's an interval, it's in one dimension, but still for your convenience, let's draw a kind of like a circle. It doesn't look like a circle. Okay, so tell me, what is the radius of this circle? Yeah, 5. And what is the center of the circle? Yeah, the origin, x equal to 0. Okay, that's it. Radius is 5, center is 0. Okay, that's it. So we have the interval, the radius, and center. Okay, let's try one more question. It's very important and it was in the past paper. And I'll repeat once more. I have never seen a past paper question without interval and radius of convergence. Okay, so let's move ahead. Find the interval and radius of convergence of the power series. 1 by 1 into 2 into x minus 2 plus 1 by 2 into 3 plus dot dot dot. Okay, it doesn't seem that friendly. So the first thing we do is we give it a name. So let sigma un be the given series. So un is, it's very clear from the pattern, 1 by n plus 1 x minus 2 the whole power n. Okay, and un plus 1. Okay, let's keep it here. And then the limit. And I'll repeat, don't forget the modulus when you're trying to find the interval and radius of convergence. Not when you do ratio test, but when you find interval and radius of convergence. Okay, so let's plug in those values and I'll repeat. A to the power m plus n is a power m into a power n. So this quantity over here, that will split. So let's cancel 1 and a 2, and this n plus 1 I already cancelled. So that's it. We end up with something like this. And again cancel And I'm sure you're very good with limits regarding infinity, and this is going to be mod x minus 2. So that's it. So I'm going to write my conclusion. Therefore, sigma un is convergent if mod x minus 2 is less than 1. It is divergent if mod x minus 2 is greater than 1. Look at this. The limit value is mod x minus 2. So I'm writing the conclusion in terms of mod x minus 2. And no conclusion. The test fails if mod x minus 2 equal to 1. But we have to analyze this. Anyway, I'll keep the conclusions over here. Okay, now look at this. I told you earlier, suppose mod x is equal to 7. So what are the possible values of x? If I put x equal to 7, yeah, modulus of 7 is 7. So that will be balanced. And if I put x equal to minus 7, of course, modulus of minus 7 is 7. So the possible outputs are, so the possible input values are plus or minus 7. Okay, using that same logic, I get x minus 2 is equal to plus or minus 1. Now what are we going to do? Yeah, we will plug in all the values in the given series. But I told you this is not that friendly, so let's go for sigma un. So we have the series. So this is the given series. This is the same as this. So let's plug in those values over here. So first let's put x minus 2 is equal to 1. Now tell me what will happen if you put x minus 2 equal to 1. Of course this will become 1 to the power n, and that is 1. So case number 1, and like I told you, we'll put sigma here, and now just go ahead, put x minus 2 equal to 1. So we get 1 to the power n, and 1 to the power n is 1, so we get this. Yeah, we can find the degree, and if you can find the degree, and if the degree is negative, which test? Yeah, limit comparison test. So we have un, we can find the degree of numerator. There is no n in the numerator, so the power 0, and the highest power in the denominator is 2, so the degree is minus 2. Now we have to create a new series with the help of this degree, and that will be Vn equal to n to the power this degree, and that is 1 by n square. And of course sigma 1 by n square is a p series with p is equal to 2, and 2 is greater than 1, hence it is convergent. Okay, so we have these facts over here. Now let's go for the limit. This is from limit comparison test. I told you before you start interval and radius of convergence, you should be very good with each and every test for convergence. And there it goes. I hope you're okay with these things. You can just plug in all these values, and okay, 1 by 1 plus, when it becomes infinity, this will become 0, so 1. Okay, now this is not equal to 0, and this is not equal to infinity. That means both sigma un and sigma vn will behave alike. But this is already convergent, so the given series must be convergent. So there goes our conclusion. Sigma un is convergent when x minus 2 equal to 1. So let's put it here. So look at this. Sigma un is convergent when x minus 2 equal to 1. Now the last possibility. Case 2, x minus 2 equal to minus 1. So like before, I think I'll write here sigma un, that is our given series, that will be sigma 1 by n into n plus 1 into x minus 2 the whole power n. Now I am going to plug in this value here, and that will give me an alternating series, and same as this. And for alternating series, we have only one test, and that is the Leibniz test. You cannot apply any other test. There is only one test, and that's the Leibniz test. So let's write un and then un plus 1 and condition number 1. What is condition number 1? Un should be bigger than or equal to un plus 1. Of course, clearly. And I told you a trick how to check in the convergence and divergence test. Number 2, limit n tends to infinity un. And n tends to infinity, so it will be infinity times infinity plus 1 is infinity. That's going to be 0. Okay, so both the conditions are satisfied. And if both the conditions are satisfied, then the given series is convergent when x minus 2 is equal to minus 1. Okay, let's put it here and proceed. Okay, now let's time for our conclusion. So look at this. Here we wrote no conclusion or test fails. Remember, no conclusion or test fails. But now I replaced these things with these facts. So I told you I'm not interested in this, but I'm interested here and here and here because they all talk about convergence. Now I told you before, mod x less than k implies minus k less than x less than k. Okay, now one more thing. I had to put this equality, and I had to put this equality here, and to extract x I'm going to add plus 2 plus 2 plus 2, and that gives me 1 less than or equal to x less than or equal to 3. Okay, let's plot it. 1 and 3. So who's in the middle? Of course 2. So the interval of convergence is closed interval 1 3, and the center of convergence is x is equal to 2, and the radius, I told you, you can imagine a circle, and the radius of convergence is 1. So radius is 1, center is 2. Okay, that's it, my friends. So make sure you work out a lot of problems in radius of convergence and interval of convergence, but first make sure you're good with each and every test for convergence. And as always, if you find the video useful, please like, share with your friends and subscribe. And I'll be back with multiple integrals. So till then, bye.